Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, great. Thank you. I'll start the lesson today. So today we are on new chapter and we are ready to discuss about the stoichiometry of the chemical reaction. Okay, let's see. So I have summarized this chapter into several points that is actually easy to be followed. So yeah, first let's see point one. Okay, can you see the picture? Yeah, I think it's okay with you, right? Okay, so this is a picture about a chemical reaction. So so we have in the left side methane with oxygen, and also in the right side there's carbon dioxide with water. So we have reactant side and we also have the product side. Okay, and it's straightforward here, right? So here is the description about the picture. The the following description is as shown. This reaction between one methane molecule, which is CH sub 4, and two diatomic oxygen molecule, which is O sub 2, to produce one carbon dioxide molecule, which is CO sub 2, and two water molecules, which is H sub 2O. So the question for this chapter is actually begin with this simple question, which is how to balance the chemical equation, so that we know that we have one methane, we have two oxygen, we have one carbon dioxide, and we have two water molecule. So here is how we do this. Okay, so first thing is that need to be pointed out here is that the substance that undergoing reaction are called the reactants, and the formulas are placed on the left side of the equation as shown in the previous picture or the previous figure. And the substances that generated by the reaction are called the products, and their formulas are placed on the right side of the equation, which is also pointed out on the previous figure. And the plus sign is used to separate individual reactant and the product formulas, and arrow, which is here. So actually in chemistry we have two kinds of arrow, and later we will see the um, coming forth and back arrow, and it will show different types of chemical reaction, right? Okay, so the forward arrow shown actually it separates the reactant and the product. Okay, and the relative numbers of the reactant and the product species are represented by coefficients. It's also called coefficients, which is a number placed immediately to the left of each formula. And a coefficient of one is not needed, so we typically will omit it. Okay. So what's the application of this point? Okay, of the figure above. So that the coefficients actually may be interpreted with regard to any amount or number unit, and so that this equation actually may be correctly read in many ways. That includes the first point is that one methane molecule and two oxygen molecules react to yield one carbon dioxide molecule and two water molecules. The second way is that 1 dozen methane molecules and 2 dozen oxygen molecules react to yield 1 dozen carbon dioxide molecules and 2 dozen water molecules. And the third possibility, actually there are still many possibilities, is that 1 mole of methane molecules and 2 moles of oxygen molecules can react to yield 1 mole of um, carbon dioxide molecules and 2 moles of water molecules. So actually what we need to point out here is that the coefficient actually is not related to the unit. It only shows the ratio, right? Okay, you see here we have 1, 2, 1, 2. Also, the next point show us the same. It's a 1, 2, 1, 2. Also, the next point also point at the same thing. The 1, 2, 1, 2 ratio. This is the reactants and the product side. Okay, so that's all that we need to really understand about, because yeah, there's about the ratio. Now point two. So a chemical equation. Now we enter the realm of a chemical equation. So actually, when we are dealing with chemistry, we are discussing about chemical equation. So what is a chemical equation that is balanced? So chemical equation is said to be balanced if equal numbers of atoms for each element is involved in the reactions. They are represented on the reactant and the product side. Okay, and this is the requirement that the equation must satisfy to be consistent with the law of the conservation of matter. Okay, so in chemistry, the conservation of matter needed to be always on your side. Okay, so let's see the previous equation that we have, which is a one methane molecule, one methane actually, one mole of methane actually, to be correctly describing the previous one, plus 2 mole of 2 unit or 2 whatever of oxygen yields, or it means, yeah, it yields, when it reacts, okay, it gives us 2 molecule of carbon dioxide and 2 molecule, I mean 1 molecule of carbon dioxide and 2 molecule of water, or yeah, H2O. So let's check if this equation actually balance or not by investigating each element, which is carbon, hydrogen, and oxygen on each side. So with carbon, we have 1 on the reactant side, product side, so it's balanced. For hydrogen, we have 4 on the left side, so 4 on the right side, so it's also balanced. For oxygen, we also have 4 on the left side and 4 on the right side, so actually it's also balanced. So it's easy, right? Okay, so this is a continuation of the previous one. So how about if we have a reaction? Okay, so this is water become hydrogen and oxygen. Okay, diatomic hydrogen and diatomic oxygen. Is this balanced? Let's check. For hydrogen, the left side is there are 2 hydrogen atom, but for the for the product side, I mean the right side is 2. So this is balanced for hydrogen. But how about oxygen? So the left side we have 1 oxygen atom, but on the right side that we have the product side we have 2. So 1 is not equal to no. This is not balanced. So we see that here, the number of hydrogen atoms on the reactant and the product size of the equation are equal, but not with the oxygen atoms. So to achieve the balance, that the coefficient of the equation may be changed as we need. But keep in mind, so this is a very important, this is a very final things, that the formula subscript cannot be altered. Okay, we cannot change this formula subscript. Okay, because it will alter the qualitative meaning of the equation. Because for example, we add sub 2 to the H2O, to the O of the H2O, I mean, which is H2O2, it is not a water again, because it will change the chemical formula, and it will represent the other things. Okay, for H2 it's water, but for H2O2 is hydrogen peroxide. Okay, so this is not the same thing. Okay, so you need to be very careful with this. So yeah, let's see. We add another coefficient. We add 2 to the coefficient of the left side. So we have 2H2O yields H2 plus O2. Is this balanced now? For oxygen, it is yes. The answer is yes, but not with hydrogen. With hydrogen, 4 is not equals to. So this is still wrong. Okay. How about if we add 2 to the coefficient of hydrogen, I mean the right side. So we have 2H2O yields 2H2 plus O2. And after some calculation, we see that these have already balanced equation. So actually, that is how simple stoichiometry works, but actually it will not be practical in later time. So I'll point to you later, but let's see example for now. Okay, so okay, I'm sorry, I, there's a little interruption for. So let's see the example. So yeah, here. First is the task to balance the chemical equation. So write a balance equation for the reaction of the molecule nitrogen, which is N sub 2, and oxygen, O sub 2, to form the dinitrogen pentoxide. So actually, we need to follow some steps. The first one is that write down the analyzed equation first. Place the reactants on the left side and the product on the right side. And then the next count the number of each type of atom that presents in the unbalanced equation for the both side. So with N we have 2 atoms on the reactant side, and for the product side we have 2. For oxygen, we have 2 on the reactant side and we have 5 on the product side. Means that the oxygen is still not balanced. So yeah, to balance the number of oxygen, and we see that here actually here there's some problem for the oxygen because the oxygen is in a uh, odd number, so this is not a multiple of 2. Okay, if this is 6, maybe this is of 4, maybe this is a little easier for us to solve this, but this is not the multiple of 2, so we need to find another solution, which is what? The yes, you know it. Okay, the least common divisor of these two numbers, 2 and 5. What is the LCD? Okay, yes, you're right. The least common multiplier, which is 2 and 5, which is 10. Okay, 2 times 5, that is 10. Okay, so we need to make this into 10. Okay, so we place 10 oxygen. It means that we multiply with 2 the oxygen, and for the nitrogen we need to multiply it 2, right? Okay, because if one is multiplied by 2, the pair is also multiplied by 2. So now we have 2 nitrogen 2 here, and yeah, we have solved the O. Okay, so the O now 5 and 2, which is 10, so it's 2. We just need to give the coefficient 5. But the nitrogen has still not in balance because of this interruption, this little modification. What we need to do next is to balance the nitrogen. So because the right side is 4, so we need to make this side to be 4 atom 2. So we need to multiply by 2. And as shown here, here's balance. 2 nitrogen, okay, 5, 2 the nitrogen, yeah, the 2 nitrogen molecule and 2 oxygen molecule. 5 oxygen molecule will combine to make 2 molecule of the nitrogen pentoxide. Yeah, that's how we equal this. And here is now your task, your exercise. Just practice with this. So write out a balanced equation for the composition. We decompose the ammonium nitrate. If you don't know ammonium nitrate, you still don't know how to write ammonium nitrate, I suggest you to check the previous chapter first, because it means that you still doesn't understand chemistry. Okay, how to write ammonium nitrate, which one is the cation, which one is the anion, what is the chemical formula of the ammonium cation and the nitrate anion. Okay, and then how to form it to be molecular nitrogen, molecular oxygen, and water. Okay, with molecular nitrogen, oxygen is the same as before, right? And 2O2, this is H2O, so this is very easy. And then yeah, you need to build the same table like this, and then you simplify it step by step. And here's the answer. Okay, so this I refill it for you, so you can check your solution later. So the answer is that 2NH4 NO3. Okay, NH4 is actually ammonium, NO3 is actually nitrate. Okay, so we have 2N2 plus O2 plus H2O for the product side. Now let's step into point 3. Okay, so yeah, it's sometimes convenient to use fractions instead of integers as an intermediate coefficient. Okay, as for before, for example, we have like this 5. Okay, sometimes it is necessary that we present a fraction for intermediate coefficient, and when balance is achieved, then we just need to multiply it to make a whole number. Okay, so we convert this fractional coefficient to integer without upsetting the atom balance. So for example, here's the example from the book, ethane. Okay, so ethane is C2H6, because this has been learned before, so you are given the molecular formula by the book. Okay, so ethane is C2H6 with the oxygen to yield the water and the carbon dioxide, and this represented in this unbalanced equation. This is C2H6 plus O2 yields H2O and CO2. This is not balanced, so yeah, maybe we'll try first to balance the C and H atoms by changing the coefficient for the two product species. Okay, so for example, yeah, we change it. Okay, because you see in the left side we have 2 carbon. It means that we need to multiply 2 to the right side to make the carbon also have 2 in the right side. So we place 2 CO2. We replace the CO2 with 2 CO2. And how about the H? Okay, we have 6 hydrogen atoms in the left side. Okay, so we may think that we need to multiply the right side H2 make it 6. Okay, by multiply 3. Okay, 3 H2O. Yeah, so far it works so well. But you see, now there are 2 oxygen atom on the left side, and we have 7. Okay, 7 total of oxygen atom in the right side, and this is not balanced. Okay, this is not balanced. So what we need to do, because we don't want to upset this right side that we have balance so far, and we see that this is a independent uh, what I say species. So this is an independent species that we can change or we can modify without upsetting the other part. So we try to multiply to make it give us 7 right on the right side. So what times 2 oxygen will give 7 oxygen? Yeah, you're right, it is 7 halves. So we just need to multiply with 7 halves. So 7 halves, so C2H6 plus 7 halves oxygen gives us 3 water and 2 carbon dioxide molecules. Okay, and then after this we just need to continue to multiply each coefficient by 2 to reduce, I mean to not reduce, to omit this fraction. Okay, so we make it to be this last form 2C2H6 218 plus 7 oxygen makes 6 water plus 4 carbon dioxide. And yeah, this has been solved. Okay, but how about if we find out uh, this equation? Okay, this is balance. Okay, you see we have 6 nitrogen on the left side, 6 nitrogen on the right side, and we have 18 hydrogen on the left side, also 18 hydrogen on the right side. But this is not the smallest whole number. Okay, because actually we can simplify it further by dividing coefficient with 3. Okay, and we need to do this because we know that there's convention know that the smallest whole number coefficient. Okay, we learn it in chapter 1. Okay, so yeah, we need to represent it with the smallest possible integer. Okay, so the correct equation is n2 plus 3h2 makes 2nh3. Okay, great. Now let's see point 4. This is I think the last one for today. Point 4. I will continue in the next point, the next video. So yeah, the physical states of reactants and products in chemical equation very often are indicated with a parenthetical abbreviation that follows the formula. So we have S for solids, L for liquids, G for gases, AQ for aqueous. Actually, it's aqueous solution, which is actually the substance that is dissolved in water. So let's see the example equation on the on the slide. Okay, so we have 2 natrium in solid state plus 2 water in the liquid state. Sometimes the water will be represented in aqueous state, but in this example is represented with liquid. Okay, it's okay. And 2 natrium hydroxide, sodium hydroxide is aqueous, and the hydrogen molecule in gas. Okay, so yeah, you see that a sodium metal is placed in water, and the reaction will produce the molecule hydrogen gas and the ionic compound, which is sodium hydroxide. And also there are special conditions that are necessary for reaction. They are sometimes designated by writing a word or symbol above the equation arrow. For example, the most common one is that we have the Greek letter delta, okay, which is like a triangle over an arrow to indicate that this reaction is actually carried out by heating or by there is a combustion that occur when we do this reaction, chemical reaction. Yeah, I think that's enough for today. I'll make the video not very long, and yeah, we'll continue on the next um on the next video. I mean, yeah, here's for you. Either you run the day or the day runs you. Here's the quote I want to share with you, and this is from Jim Rohn. Okay, so That's the end of the video for today. Thanks for watching, thanks for following so far, and here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science-with exploits.unaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful. Goodbye, see you on the next episode.